Hello friends and dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is set 2 of 5 good problems on the chapter of polygons. If you have not watched the set 1 solving of 5 good problems, then I strongly suggest and request that you please watch that video as well to have a good practice of 5 good problems. So this video is part of the playlist Maths 8 Hot, where HOT Hot means high order thinking, where I come up with relatively harder problems on every chapter as and when they are completed in the other playlist, that is CBSE Maths 8 RS Agarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving 5 good problems of set 2 on the chapter of polygons. Okay, so I have the problems, 5 good problems of set 2 on the left hand side. I hope the fonts are big enough so that you can read them, read the problems. Uh, the link to the PDF of these 5 good problems of set 2 will be also there in the description below. Okay, so let's start solving the problems. Question number 1 says, let P be a polygon whose sum of exterior angles is E and the sum of interior angles is I. If E is equal to twice I, then P must be a triangle, quadrilateral, pentagon and hexagon. So it is asking what is the number of sides of the polygon P. P is a polygon. It is not a regular polygon but a normal polygon. So we know that for a polygon, for a polygon, for the mm, sum of sum of exterior angles. Now, for solving these problems, you must be aware of all the theoretical concepts, formulas of polygons. See, if you have not watched my theoretical videos on the other playlist, CBSE Maths 8 RS Agarwal, on this chapter of polygons, that you can watch those videos as well. It will give you a good foundation about the polygons, their geometrical properties and the formulas. So sum of exterior angles of polygon with n sides we know is equal to 360 degree. Okay, we know that for a polygon of n sides, the sum of the exterior angles is always equal to 360 degree. Okay, and the sum of interior angles is equal to 180 multiplied by n minus 2, where n is the number of sides, this much degree. This much degree is the sum of interior angles. Okay, now it is given that E is, so in this problem we have E is equal to 360 degree. I am ignoring the degree, and I, that is in this problem I is said to be the sum of interior angles, which is, we can say, will be 180 multiplied by n minus 2. Now it is given that E is equal to twice I. So we can say that E is 360. 360 is equal to twice I will be 2 into 180 multiplied by n minus 2. So we have this equation in n. Now this implies, if we simplify the equation, it becomes 360 is equal to 2 multiplied by 180 is 360 multiplied by n minus 2. So 360 we can cancel from both sides, or you can say we can divide both sides of the equation by 360 and we get 1 is equal to n minus 2. So this implies n is equal to 1 plus 2. equals to 3. So this is basically a triangle, and a triangle. Now, okay. So this will be, n is 3 means it is a triangle. So the correct choice is A. Now you can also quickly verify. Now the each interior angle. So each okay. Uh, if you put n equals to 3 over here, obviously it will work. If you put n equals to 3 over here, it is becoming I is becoming 180, and definitely E is 360, because the sum of exterior angles of all the sum of all exterior angles of a polygon of inside is 360 degree. It is independent of the number of sides. Okay, so n is 3, so the correct choice is A, that is the P is a triangle. Okay, let's do question number 2. So a figure is given. ABCD is a regular pentagon. Let me quickly draw a pentagon. Okay, so this is let me quickly orient it properly. No. Okay, anyway, so I can't. Okay, so this is the pentagon, and given pentagon, the vertices are A, B, C, D, and E. And it is saying that it is a regular pentagon. That means all the sides are equal, and it has 5 sides. The bisector of angle A meets the side CD at M. So the bisector of A meets the side CD at the point M, and it is asking to find the what will be this value, the measure of angle AMC. Let's say this angle is x degree. Let's say this angle is x degree. Okay. Now we know that AM is bisecting the angle A of the polygon. That means this angle will be equal to this angle. So it will be equal to this angle. Now ABCDE is a regular pentagon. So each interior angle, or we can say from this diagram, we can say okay. So each interior angle using the formula will be 180. We know the formula is 180 multiplied by n minus 2 divided by n, where n is the number of sides of the regular polygon. So this is the value of each interior angle. Now for this problem, n is 5, since it is a pentagon. So we have 180 5 minus 2 divided by 5. This is equal to 36 multiplied by 3. This is equal to 108. So each interior angle is 108. Okay. Now so we have let's say I'm rather than writing the angles as A, let's say if I as using the 3 vertices, let's name the angles of all the polygons. Then it will be easier to refer them to form an equation. So I am assuming that the angle AMC is x degree, and let's say this angle is y degree, and this angle we know is an interior angle of the polygon. It will be 108 degree. Also this angle is an interior angle of the polygon. It will be 108 108 degree. Now instead of writing I really don't have much space. Let's give some names. Let's say this angle is let's say P degree, and this angle, that is angle A, Angle ABC is P degree, angle AED, let's say, is Q degree. Let's say this angle, that is angle BCM, is, let's say, Z degree, and this angle, that is EDM, let's say this angle B, uh, R degree, R degree. Okay. So we are using, I hope it will not be a problem if I am using a lot of letters. And also this angle, the two angle bisectors of the angle A, let's say these angles are S, let's say S degree, and let's say this be T degree. Now what do we have? We have named all the angles. Now definitely the ABCDE is a regular polygon. So we have S degree is equal to T degree, because they are angle bisectors of the angle A. It will be equal to, angle A is an interior angle which is 108 degree, and so it will be divided by 2. So this is 54 degree. Each of angle S and T will be 54 degree, because angle A is an interior angle of the regular pentagon, which is 108 degree, and angle S and T are both equal, and they are bisectors of angle A. So each of angle S and T will be 108 degree by 2, 54. Also we know that angle P degree will be equal to angle Q degree, will be equal to angle Z degree, will be equal to angle R degree. They are all internal angles of the regular pentagon, and hence they will be each equal to 108 degree. Okay. Now we have to find x. Remember that we have to find x. Now consider the polygon or quadrilateral in, let's say, quadrilateral. What we know that since okay, we know that in a quadrilateral the sum of all the interior angles is equal to 360 degree in a quadrilateral. So in quadrilateral ABCM, in this quadrilateral we have S degree, we have S degree plus P degree plus Z degree plus X degree is equal to 360 degree, because S degree, P degree, Z degree and X degree, these are all the internal angles of the quadrilateral ABCM. And we know that from the properties of quadrilateral that the sum of all the interior angles of a quadrilateral is always 360 degree. So we have this. Okay, now we can name this equation or result as equation number 1. Again, in quadrilateral, in the other quadrilateral, that is AMDE, in the quadrilateral AMDE will have the same result, that is the sum of its internal angles should be equal to 360 degree. So we must have T degree plus Q degree plus R degree plus Y degree is equal to 360 degree. Okay. Now in both the equation, the right hand side are equal to 360 degree. So we can equate the LHS of both the equation 1 and 2. So we can say that from equation 1 and 2, we can say that S degree, now I am ignoring the degree, I am just considering the values of the measures of the angles. I'm ignoring the degree. So S plus P plus Z plus X should be equal to T plus Q plus R plus Y. Okay, now this implies we already know that S is equal to T. S is equal to T. We know S is equal to T, so we can cancel out S and T from both the sides. We also know that P is equal to uh, P is equal to Q is equal to Z is equal to R. Okay, so we can, since P is equal to Q, we can cancel out P and Q from both the sides. Also, since Z is equal to R, we can cancel out Z and R from both sides. And so we are left with X is equal to Y. X is equal to Y. Now we also know that also we must have x degree plus y degree should be equal to 180 degree, because the segment AM is incident on the line on the segment CD, and uh, they are I forgot the term. Since the ray AM is incident on the segment CD at the point M, the sum of all the angles on the side of the line segment CD should be equal to 180 degree. I hope you are familiar with this result. So x plus y degree, x degree plus y degree will be equal to 180 degree. This means that x plus y is equal to 180, and we have already found that x is equal to y, so we can say x plus x is equal to 180. So this implies 2x is equal to 180. So this implies x is equal to 180 by 2, which is 90. So x degree is equal to 90 degree. So the correct choice is C. Angle AMC is 90 degree. So basically we used the concept of the sum of all internal angles of a quadrilateral is 360 degree, and we considered the two adjacent quadrilaterals, that is ABCM and the other quadrilateral AMDE, and we, since the sum of their internal angles will be equal, we equate them, and we also know that some angles will cancel out because they are just the internal angles of the given regular pentagon. Okay, let's do problem number question number 3. Question number 3 says the exterior angles of a pentagon are in the ratio 6:3:4:3:2. Its largest interior angle is okay. Now if the exterior angles, if the ratio of all the exterior angles of a pentagon is given, we can easily find out each of the exterior angles, since we know that the sum of the exterior angles of any polygon of any sides of any polygon is always 360 degree. So we assume from the concept of ratio and proportion, from the chapter of ratio and proportion, when we need to find some quantities whose ratio are given, we always assume their values to be using the parts of the ratio as multiple of x. So let assume the exterior angles are based on the given ratio 6x 3x. I'm ignoring the degree, actually it should be let's say 6x degree, 3x degree, 4x degree, 3x degree, and 2x degree. Okay, so these are we are assuming that the exterior angles of the pentagon are 6x degree, 3x degree, 4x degree, 3x degree and 2x degree based on the given ratio. Now we also know, so this implies we know that the sum of the exterior angles of any polygon of any side is always 360 degree. So we must have 6x plus 3x plus 4x plus 3x plus 2x. This degree is equal to, you must have 360 degree. Now ignoring the degrees, we can say that if we sum up all the x terms on the left hand side, we get 9x, 13x, 16x, 18x is equal to 360. This implies x will be equal to 360 divided by 18, which is equal to 20. So x is 20. Now it is asking what will be its largest interior angles. Now one concept is that when will be which interior angle of a polygon will be largest. So the concept is that we have some polygon, let's say it is not a regular polygon, some irregular polygon, that is the sides are of unequal length, and so let's say AB is a side of the polygon. We extend the side AB. So this is, let's say, the interior angle x degree, and this is the y degree, let's say exterior angle. Now it is asking what will be the largest interior angle, what will be the maximum value of x. Now the largest interior angle will be when the exterior angle is minimum. When y will be minimum, only then x will be maximum, because x plus y, we know x plus y is constant. X plus y is always equal to 180, or x degree plus y degree is equal to 180 degree. So if you have to maximize, if you want to have maximum value of x, definitely y will be minimum. So we have to find the minimum exterior angle, then only we can find the maximum exterior angle just by subtracting from 180 degree, because we know that the sum of the minimum, the sum of the largest interior angle and the minimum exterior angle will be 180 degree. Okay, now let's find what is the minimum exterior angle. So we have x equals to 20. So definitely this will imply minimum exterior angle will definitely be as per the minimum part of the given ratio, that is 2. So it will be 2x, which is equal to 2 multiplied by 2, which is equal to 40 degree. 40 degree is the minimum exterior angle. Hence we can say that the maximum interior angle, when the exterior angle is minimum, then its corresponding internal angle is the maximum. So we have maximum internal angle will be equal to 180 degree minus 40 degree, that is equal to 140 degree. So 140 degree is the maximum internal angle. Hence the correct choice is D is the correct choice. Okay, let's do question number 4. The measure of an interior angle of a regular polygon of n sides is 120 degree. Okay, then the measure of each interior angle of a regular polygon of 3n sides is. Okay, it is given that the measure of an interior angle, we know each interior angle, the formula is each interior angle of a regular regular n-gon. Now n-gon means, in short, n-gon polygon means a polygon having n sides. So each interior angle of a regular n-gon polygon we know is equal to 180 multiplied by n minus 2 divided by n, where n is the number of sides of the regular polygon. Okay. This for it is given that the measure of an interior angle of a regular polygon of n sides is 120 degree. So we must have 180 multiplied by n minus 2 divided by n is given to be 120 degree. Now obviously this is actually this much degree. This much degree. Now we can ignore the degree from both sides. So we get a linear equation. We will have a linear equation in n, and we can easily solve for n. Now please note that we need to understand whether we actually need to find each interior angle of a regular, we actually need to find the value of n or not, because let's see. So now we know that for a regular polygon having n sides, the each interior angle is equal to 180 multiplied by n minus 2 divided by n, that is given to be 120. Okay. So I was just wondering, do we need to actually find the value of n? Without using the value of n, can we find what will be the value of each interior angle for a regular polygon of 3n sides? Okay. Now, so for a regular polygon of 3n sides, each interior angle will be 180 multiplied by 3n, since now the number of sides is 3n minus 2 divided by 3n. Now using this value, we know this 180 multiplied by n minus 2 divided by n is equal to 120. Using this result, can we find the value of 180 multiplied by 3n minus 2 divided by 3n? I don't think it will be easy. So let's anyway find the value of n. Now from this equation, so we have 180 multiplied by n minus 2 divided by n is equal to 120, ignoring the degrees. Now we can cancel the 0 from both sides, and we can do, that is, we can divide both sides by 10, and we have this. Again we can cancel both the sides. We can divide both the LHS and RHS by 3, and we get 6, not 3 but by 6 we get 3 and 2. So we get 3 into n minus 2 divided by n is equal to 2. By doing cross multiplication, we get 3 into n minus 2 is equal to 2n. Further simplifying, we get 3n minus 6 is equal to 2n. This implies we get 3n minus 2n is equal to 6. This implies n is equal to 6. So the number of sides of the regular polygon will be 6. That is, it is a regular hexagon. So we have found n. Now we need to find the value of this. That is, this will be the value of each interior angle if the number of sides is 3n. Now in this we can put the value of n as 6, and we will get 180 multiplied by 3 into 6 minus 2 divided by 3 into 6. This is 180 multiplied by 18 minus 2 is 16 divided by 18. So this cancel this, and we have 160. So a 160 degree will be the value of each interior angle if the number of sides of the regular polygon is 3n, and hence the correct choice is D. D is the correct choice. Okay. Let's do question number 5. How many non-overlapping triangles? How many non-overlapping triangles can be drawn in an n-gon polygon by joining the vertices? Now, n-gon polygon means a polygon having n number of sides. Okay, so how many non-overlapping triangles can be drawn in a? Okay, uh, so let's draw a polygon. It is not a regular polygon. It is given a simple polygon. So let's say this is a some polygon. Now, just for the sake of understanding, so this is the polygon A, B, C, D, E, and F. Now, what does it mean by how many non-overlapping triangles can be drawn? This means that by joining the vertices. Now, I can join the vertices F and B and can have the triangle AFB. This is the triangle AFB. Now, by non-overlapping triangle means I cannot join triangle AE because the triangle AFE and AFB will become overlapping triangles. They are intersecting with each other, so I cannot have this triangle. So another non-overlapping triangle can be by joining the vertices F and C. So this is another non-overlapping triangle. So we got so far two two non-overlapping triangles, and the third and the last two vertices that we can join is F and D, and we get two more non-overlapping triangles. So how many non-overlapping triangles we made for this polygon where the number of sides is is what is the number of sides of this polygon? AF, FE are the sides, ED, DC, CB, and AB. So 1, 2, 3, 4, 5, 6. So this is a hexagon. So we can see for n is equal to 6, the number of triangles, number of overlapping triangles is equal to 4. Okay. Now I don't know if there is any formula that will relate the number of non-overlapping triangles and the number of sides of a polygon. So in terms of the number of sides of a polygon, what will be the number of non-overlapping triangles? If there is any formula I am not aware of, also I will not be able to derive that results or formula. But intuitively I am just using my guess and intuition, and I can see that if I take a hexagon, I can see that there are 4 non-overlapping triangles, which is somewhat 4 is equal to 6 minus 2, where 6 is the number of sides of the polygon, that is, it is a hexagon. Now, will it be true? So can we say that the number of non-overlapping triangles for a polygon having n sides will be n minus 2? Now, so for that we have to check a few more values of n. Let's say we take now for a triangle, obviously for a triangle do not have any diagonals, so we definitely should not consider a triangle as a polygon. So let's say a quadrilateral. How many diagonals are, how many non-overlapping triangles can we make? We can only make 2. ABCD. If ABCD is the quadrilateral or a polygon having 4 sides, by joining the vertices A and C, we can see we can make 2 non-overlapping triangles. So for this quadrilateral, we can see that n is equal to 4, and the number of non-overlapping triangles is equal to, we can see clearly, 2, which is 4 minus 2. So it is kind of n minus 2. Let's see if it is the case for a pentagon. So with basically I am doing a trial and error method. I am checking whether n minus 2 will be the correct result or not. So I am taking a few values of n. Definitely I cannot take 3 because 3, if n is 3, then it is a triangle, and triangle we cannot make any triangle a triangle we cannot make any triangle inside a triangle. So at least we have to take a quadrilateral. So for quadrilateral, I checked that the number of non-overlapping triangles is coming out to be 2, which is basically the number of sides minus 2, because the number of sides for a quadrilateral is 4. Let's see what is the case for a pentagon. So this is a pentagon. So let's say A, B, C, D, and E is the pentagon. I can create a triangle ABC, join A and C, and I can create E and C. So I can clearly see there are 3 non-overlapping triangles formed by joining the vertices of a pentagon. So for a pentagon, we see n is equal to 5, and the number of triangles, these should be non-overlapping triangles. I am not writing non-overlapping. I hope you will understand. Number of non-overlapping triangles we see is 3, which is 5 minus 2. So in all the cases, at least for the cases of n equals to 4, n equals to 5, and n equals to 6, we can see that in all the cases the number of non-overlapping triangles is coming out to be the number of side minus 2. So based on this intuition, it is my I think the answer will be n minus 2. I am not sure, but I think this should be the answer. The correct choice is C. I could be wrong. If you think I am wrong, and if you have a justification why I am wrong, you can please let me know in the comment section. I will appreciate that. But I think it will be a better idea if you can somehow have a formula how many non-overlapping triangles you can have for a polygon of n sides. I was initially thinking whether it is related to the number of diagonals of a polygon of n sides. We know that the number of diagonals of a polygon of n sides is n into n minus 3 divided by 2. So this is the number of diagonals. Now from the number of diagonals, is it possible to find the number of non-overlapping triangles? I am not sure, I don't know, but that was my initial thought, and I failed to formulate any result of what will be the number of non-overlapping triangles based on the number of diagonals in a polygon of n sides. So I thought about doing solving this problem using trial and error. So we checked for n equals to 4, equals to 5, equals to 6. It is coming true that the number of non-overlapping triangles will be the number of sides minus 2. Let's quickly check one more result. Let's say let's check for a heptagon, that is a polygon of 7 sides. Let's see, 1, 2, 3, 4, 5, 5, let's say 6 and 7. So let's say the heptagon be A, B, C, D, E, F, G. So this is the heptagon. We are having n is equal to 7. So how many triangles can be formed by joining two vertices? I can join the vertices G and B and form a triangle, this one. I can form the vertices G and C and form another non-overlapping triangle, this. I can connect the vertices G and D and form another non-overlapping triangle, this. I can connect G and E and form another non-overlapping triangle, this, and there is another non-overlapping triangle left, which is this. So number of for n equals to 7, we can see the number of non-overlapping triangles is 1, 2, 3, 4, 5, which is equal to 7 minus 2. So based on this fact, I can say, even though I cannot say for 100% surety, but I would have answered the correct choice as n minus 2. So with this, I come to an end in solving another set of 5 good problems on the chapter of polygons. I hope this set of problems will give you some more idea of how to solve the problems on polygons, and will give you, so keep on while solving these problems, keep on taking notes of any new concepts that you are learning while solving the problem of any chapter. And so these notes should be very handy while giving any exam. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. I will come up with more sets of these kind of 5 good problems on the chapter of polygons. So please stay tuned in the same playlist, that is Maths 8 Hot. And very soon I will start the next chapter from the textbook of author R.S. Agarwal, that is quadrilaterals, in the other playlist, that is CBSE Maths 8 R.S. Agarwal. I will end the video here. Thanks for watching, and until the next video, take care and bye.